This video is a continuation from the previous chapter, which was looking into ratios and rates as part of that. So when looking at rates, the hint is to look at the target units, e.g., for example, if required a rate in kilometers per hour, that means that the distance should be in kilometers and the time should be in hours. So look out for what units you're required, and that usually guides you to what you're supposed to do. So, for example, it says find 1/8 of 7.24 kilometers in giving your answer in meters, right? So, firstly, we have 1/8 of 7.24 kilometers. But the question asks us to give the answer in meters. So I would say the first thing that you have to do is change distance from kilometers to meters. And to do that, I prefer using the approach. So people use different methods. Some just by knowing that 1 kilometer is equal to 1,000 meters, they would know that 7.24 kilometers is in meters. That's 7.24 times 1,000, right? And then they get the answer is 7,240 meters. Or using the same approach, I mostly prefer using proportion. So if you think that you understand that better, so that's saying if 1 kilometer is to 1,000 meters, therefore 7.24 kilometer is going to be more. And this then translates to 7.24 over 1 times 1,000 and gives us 7,240 meters. So you get the same answer, just that some people can easily go to the direct method, or you have to use proportion just to cross-check that you're not making a mistake. So firstly, change distance from kilometers to meters. And then after that, number 2, then simplify. So to simplify, we go back to what we had here. Now that we know that it's 1/8 times 7,240 meters. 8 into 8, 1, 8 into 72, that's 9, into 4, 0, remainder 4, into 40, that is 5. So that's going to be 905 meters. Then the next question says 5/12 of 3 hours and 36 minutes in hours and minutes, right? So when you're dealing with time, the best way is to not work with both minutes and hours. You have to first convert to minutes, make the calculation, and then convert back to hours, because it's much easier that way. Unlike working with, because with hours there's a trick part of saying 1 hour is 60 minutes. So once you're trying to divide by fractions and things like that, then you would lose track of what a fraction is. So it's easier to use the same units and then convert back. So again, 1, change time to minutes. So we have 3 hours 36 minutes, which is the same as saying we know that 1 hour is 60 minutes. So 3 hours is going to be 3 times 60 plus 36, which is going to be equal to 180 plus 36, which is 216 minutes. So after this, the second part is to calculate, right, the question that we had. So it's 5 over 12 of 216, right? And that gives us 90. Oh, that's 90 minutes. And then number 3, because we were asked, the question specifically asked to give the answer in hours and minutes, so we have to convert back. Convert time to hours and minutes. So 90 minutes. So knowing that 1 hour is 60 minutes, so 60 minus 90 minus 60, that's 1 hour 30 minutes. And that's how you find the final answer. Then the next question says change 1 hour 30 minutes to seconds, right? So first we change hours to minutes, and then minutes to seconds. So we have 1 hour 30 minutes. In minutes, that's going to be 1 hour is 60 minutes plus 30 seconds plus 30 minutes. Then that's 90 minutes. And then we do proportion again, just knowing that 1 minute is 60 seconds. What about 90 minutes, right? 90 is, then we expect more. Then that's going to be 90 over 1 times 60. And that's going to give us 5,400 seconds. And that's our answer. The next question says, a car traveled 50 kilometers in 20 minutes. Find the speed in kilometer per hour. So the hint is per, it means divided by, in kilometers per hour, right? So if we already have the distance in the kilometers, which is great, but now we need the time in hours. So there are different approaches to doing a question like this. So one of these, for example, I would say change time to hours. So we have 25 minutes. So if 2 hours, right? So we know that 60 minutes is to 1 hour. 25 minutes, we expect less, right? Since 25 is less than 60, which means it's going to be 25 over 60 in red times 1. And then when we simplify this, 5 is 5, 5 is 12. So that means 5 over 12 hours, right? That's 25 minutes. And then now we calculate the speed. So speed, even looking at the units, you see that it's units of distance divided by units of time. So speed is distance divided by time. In this case, distance in kilometers and time in hours. So the distance, we have it as 50 kilometers. The time, we don't always have to simplify. You can make it a fraction if you have a calculator, but in this case, you can leave it as is, 5/12 hours. And when dividing by a fraction, you know that you then invert it to multiply, and 5 into 5, 1, 5 into 50, that's 10. 10 times 12, that's 120 kilometers per hour. And then the next question says, which of the two is a better deal in terms of price? 5 kg of pork for $23.75 or 8 kg of beef for $50. So we first have to evaluate the rate. So rate, right, which is price per kg, to say how much does it cost per kg. So we have pork is going for $23.75 for 8 kg. So to find how much then that costs, we divide and we get $4.75 per every kg. And for beef, we have $50, right? That's for 5 kg. And for beef, we have $50 for 8 kg. And when we compute that, we get $6.25 per kg. And then the second step is to compare the prices per kg, right? Because a kg is a standard measurement. The price is per kg. So we have $4.75 versus $6.25. And we can see that pork is cheaper. So therefore pork is a better deal. Because they said in terms of price. Because we're now saying if we take 1 kg of each, right? That means that the mass is the same. But what makes it different is the price itself, the value per kg, which means beef is more expensive than pork. So pork is a better deal because it's cheaper. Okay, so we have this question that says, the distance between any two consecutive telephone poles along a road is 15 meters. A car travels from the 1st to the 9th. So things to note, we have 15 meters, and a car travels from the 1st to the 9th. So from the 1st to the 9th in 6 seconds. So that's also key. Calculate the speed. So we want to see the speed and in kilometers per hour. So units are important and the keywords are important. So to understand what we have, we first need to find, I think illustration is the first important. So illustrate the problem to visualize what it's asking. So we have from one pole to another, let's say these are 2 poles, it says it's 15 meters. But then we're told that it travels from the 1st to the 9th pole, right? So now we have 9 of these poles. So let's say when they're 9, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. knowing that each of these is 15 meters. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 15 times 8, because we get 8 of the distances between 9 poles, which is going to be 120 meters, right? So this is just the calculate total distance in kilometers, because the speed is going to require us to have in kilometers. So again, we said 15 times 8, we get 120 meters. So 120 meters, 2 kilometers. So again, 1,000 meters give us 1 kilometer. What about 120 meters? It gives us less. So 120 over 1,000 times 1, and then we get 0.120 kilometers. Now the next part is to calculate convert the time. Convert the time to hours. So an important thing is, we're told that the 6 seconds is for all the 9 poles. It's not for just one pole. It's for distance. It's for covering all the 9 poles. So we just need to convert 6 seconds to hours. So we first need to find out how many seconds are in an hour, right? So 1 hour is made up of 60 minutes, and each minute is made up of 60 seconds. So that means that 1 hour is going to be made up of 3,600 seconds, right? So we know that if 3,600 seconds give us 1 hour, what about 6 seconds? That's going to give us less. We invert 6 over 3,600 times 1. 6 into 6, 1 is 36. 6, 0. So that means that we have 1 over 600 hours is our time. And then the last thing is to calculate the speed. Again, speed, distance over time. And our distance is 0.12 kilometers over 1 over 600 hours. And when we compute that, we get 72 kilometers an hour. So after an hour, at this rate, the car would have covered a distance of 72 kilometers. So you can try some questions extracted from the Mathematics Today textbook, number 1 to number 4, and yeah, give them a go. So the next part of the worksheet is talking about percentage increase and decrease. We had dealt a little bit with that in the ratios, in the video ratios, but this is also an additional part. So it says a woman earning $275 had her salary increased by 5%. Calculate her new salary, right? So we're saying new salary is equal to, if she was getting 100%, now she's getting plus 5%, right? Because a completion of something is 100%. So the old salary was 100% of itself, but the new salary is adding 5% to that 100%, right? So now she's getting that of the $175, which means she's getting 105% of $275. And knowing percentage, this is going to be 105 over 100 times 275, which is going to give us $288.75. So that's how we approach that. And then the next says, during a marathon race, an athlete loses 2% of his mass. At the end of his race, his mass is 67.13 kg. Calculate his mass before the race. So highlighting that this is at the end, so this is the final. And we want his mass before. We know that he lost 2%, right? So initial mass was 100% of this new final, right? Was 100%. Initial mass was 100%. But then he loses 2%, which means it's got 100% minus 2%, which is 98%. Now we're being told that this 98% has a value of 67.13 kg. What about 100%? It has to be more, right? Because if you have lost 2%, then your initial one must be more. So 100% is more than 98%. So that's going to be 100% over 98% times 67.13 kg. And that gives us 68.5 kg. So that is the initial mass. And you can give a try to this worksheet, which also gives more practice questions on increase and decrease in various ratios. And exercise 2 as well also does that.